Starting on looking at questions from past examination papers on secular measure. Now, that's the question we're going to do there. Now, what I've underlined, the perimeter is equal to 20, is the important thing, right? So our formula here is finding the arc length, because that will help us find PQ. So we know PQ is going to be equal to our r theta, right? Now, so this, if this is r theta, this is also radius. Now, we must equate that perimeter to 20. So we go 20 is equal to our perimeter, we add the distance right around that shape, which gives that. Now, this is going to be 2r plus r theta is equal to 20. Now, we need to make theta the subject. So this is going to be 20 minus 2r is equal to r theta. So the final stage is dividing by r. So we are going to go theta is equal to 20 over r minus 2r over r. Now there the r crosses out, so we have got 20 over r there minus 2. So this is what we were required to show in part 1. So in short, you use the information that's given. In this case, we're given the perimeter is equal to 20. We have our formula for the arc length, which is r theta. Up to there, we need to find the area of the sector, and we know area is half r squared theta. So we are going to go, therefore area is equal to our half r squared. We found that in part 1 theta was 20 over r minus 2. So all we need there to do is now simplify that. So half into 20, that's going to be 10. R squared divided by r, that's going to be r. Half of 2, that's 1. So you have minus r squared. So this is the area in terms of r. So this is what you are required to do, right? So now part 3, we're given r is equal to 8. So I've substituted my r equal to 8 on my diagram. I want to find the length of the chord PQ. I've underlined the word chord here because some will mistake it for the length of the arc. So that's my chord there, right? The first thing, I calculate my theta. So this is going to be 20 over my 8 minus 2. And if you do this on your calculator, you'll see this gives 0.5. So it means this angle here, which is your theta, is 0.5. Now, to get the opposite side, we know that's the triangle. And from IGCSE, we can see we need to use the cosine formula. So you need to remember your cosine formula. O squared is equal to P squared plus Q squared minus 2 of PQ cos of O. All right. So remember the cosine formula. Now, if you substitute, P is 8. So this is going to be 8 squared plus 8 squared minus 2. 8 times 8 is 64. And this is going to be cos of 0.5. Remember, your calculator should be in radians as you're doing all this. If you do that on your calculator, you get 15.669. And to get your side PQ, therefore, you're going to go square root and you get 3.96. So importantly, remember your cosine formula here. Question there on secular measure, we are given that diagram there. Now I would want to find this angle first here. Now how I do that, so this is angle AOC. How I do that, I know this whole angle is 90, which is going to be equal to pi over 2. I subtract pi over 3 and I get pi over 6 here, right? The next thing, I would want to find side OC. Now side OC this is my adjacent here and this is my hypotenuse, right? Adjacent hypotenuse would be cos pi over 6 is equal to adjacent, which is my OC, over hypotenuse, which is 12. So I get OC is going to be equal to 6 root 3 there, right? So I found that side. So it is the side OC there. I would want to find AC now. Now your AC, this is going to be opposite side here, and I'm going to use it with hypotenuse. Opposite hypotenuse is going to be sine. So sine pi over 6 is equal to opposite, which is your AC, over your hypotenuse, which is your 12. So I get my AC as equal to 6. So I get my AC there. Now that I've got everything I need, I'm going to put down the strategy for my formula. I'm going to go area of the shaded region is equal to area of the whole rectangle minus area of the triangle minus area of the sector. Now, this is going to be equal to, so the area of that is going to be 12 times 6 root 3 there. Then I'm going to subtract, I'm going to go half base, which is my 6 times 6 root 3 there, minus, I'm going to go half half r squared theta, so that's 12 squared. My theta is pi over 3, right? If you're going to do that on your calculator, you get 54 root 3 minus 24 pi. Right, so importantly on this, for this question, you need a strategy. We had a formula here. You need a strategy before you can execute your plan. And we calculated the missing sides first before we can actually put anything down. Question on circular measure is, we are given that diagram there. Now we know area is half r squared theta. We want to find the area shaded, so we go area of the bigger sector minus area of the smaller sector. So the bigger sector, we go half r squared, that's going to be 16 squared. Our theta there is 0.8, right? Minus, we are going to go half r squared, so that's going to be 10 squared by 0.8, and if we do that on our calculator, we get this as 62.4. so this is our area shaded there. So again, like we're doing with the other questions, we need a strategy for our formula. Area of shaded is area of the bigger sector minus area of the smaller sector there to get our area as 62.4. Question, we want to find alpha given the perimeter of that there. So we need to find arc AC first, and since this is r theta, this is going to be 10 alpha. We also want to find arc BD. Again, r theta gives 16 alpha. So we found this is 10 alpha and then this is 16 alpha. So we want to add those up. So we're going to go 10 alpha plus 16 alpha plus the 12 for the two sides is equal to 28.9. right? If we add these, we get 26 alpha is equal to 16.9. so this gives 16.9, and if we divide, we're going to get alpha as 0.65, and remember, this is radians.